Another option to deal with an unbalanced demand in the transportation problem is to change the structure of the model. For the unbalanced demand in the transportation problem, that is when the sum of the offered products, the supplied products, is unequal to the sum of the products demanded by the warehouse, we can change our equality constraints in the model. That means by default, all the constraints in the model are equality constraints. Now, instead of changing the input data like in the first option, we change these operators. We change some of our equality constraints to inequality constraints. In case that the supply at the factories is in total bigger than the demand at the warehouses, though the warehouses are the limiting factor, the demand of the warehouses needs to be fulfilled, we can leave the shipments to the warehouses with the equal operator. There's no need to change, but we need to change the shipments from the factories to the warehouses to the smaller or equal operator. Let's have a look at the mathematical model from the last session. So we can leave these four constraints unchanged in this situation, but we need to replace the three equal signs by smaller or equal signs, because in total we cannot guarantee that the total supply at the factories is transported to all the warehouses, because the supply is bigger than the demand from the warehouses. Now, if the opposite situation happens, the supply at the factories in total is smaller than the total demand at the warehouses, then the factories, the supply points, become the limiting factor, and we keep our equal sign as it is. Back to the model. Though, if the factories in total offer less than what is required by the warehouses, these first three equalities can remain the same. We keep the equal sign. However, we have to tell the model that we will not be able to fulfill the total demand of all the warehouses, and we need to replace these equal signs, these four equal signs, by smaller or equal signs. Of course, we need to, if we want to solve this problem via Excel, we need to tell our Excel solver about this change. And then we can simply solve everything again, for example, via Excel, and we get the final solution. The point is, we need to pay attention if the supply is bigger or smaller than the total demand. We need to account for this. On the other hand, we can just read the solution to this model from the Excel solution, the solution provided by the solver. And in contrast to option number one, where we manipulate the data, we do not need to reinterpret the solution. We can work with a given solution as it. This is one advantage of this approach. Now, in order to practice these extensions to the transportation problem, like the unbalanced demand and the infeasible routes, I would like you to do a self-study exercise. So please model the following transportation problem that has only two factories, two supply points, and four demand points. The transportation cost is given here. The demand for each warehouse is given in the lowest row, and the supply from each factory is given in the rightmost column. Solve this problem via Excel. First of all, model the standard version of this problem in Excel. You will see that the total demand is unequal to the total supply. So you need to do some modifications to the standard modeling approach. Do these modifications and solve the problem. This is a graphical representation of the problem, and here are some more individual steps that help you to solve this problem. Good luck with this.